Like interfaces, classes can contain properties and methods, but unlike interfaces, classes provide the actual implementation details. Here I've got the shell of a reference item class. There are a couple of different ways to define properties on a class. The first is just to define a new variable inside the class. This property is named number of pages. It's a number, and I can get or set its value on an instance object just using the normal dot syntax we've already seen. The second way to define properties is to create custom accessors. Accessors are getter and setter functions that give you more control over how property values are set and retrieved. They have their own special syntax. In this example, I'm creating accessors for a new property named editor. You define them by using the get and set keywords. Accessors are basically just functions, but they both have the same name. Since my property will be named editor, that's the name I use for both accessors. The getter will always contain an empty set of parentheses after the name. You can optionally set a return type as I did for mine. The setter must be passed exactly one parameter, and you are not allowed to specify a return type for it. Inside the bodies of the accessors, you can perform any special logic you need for the property. Consumers of the class will access the property with the dot syntax just like any other one. Methods are pretty straightforward. They're just functions defined inside the class. Here I've got a method named printChapterTitle that takes one number parameter and doesn't return a value. You also call methods on a class using the dot syntax we've seen many times already. It's very common to initialize properties on a new object by passing parameters to the class's constructor and then setting the properties equal to the parameters inside the constructor. Parameter properties are a shortcut for that common pattern. In this simple class, I have a name property. The constructor takes a single parameter which is then assigned to the property. I accomplish the same thing in this second example with much less code. I don't explicitly declare a new property. Instead, I place the public keyword in front of the constructor's parameter name. That tells the TypeScript compiler I want a property with the same name as the parameter and that it should be set equal to the value passed to the constructor. It's a nice shortcut that eliminates the explicit property declaration and the assignment inside the constructor body. Static properties are properties of the class itself, not of the class instances like the properties we've seen so far. In this library class, I've defined two properties. The first is a parameter property named name, which will be available on all instances of the class. Each instance can set the property equal to whatever value is appropriate for that instance. The second property is named description, and I've prefixed it with the static keyword. It will therefore only be available on the class and not on instances of the class. If I declare a new instance of the library class and assign it to a variable named lib, I can then reference the name property on that instance. However, if I want to reference the description property, I must reference the library class itself. Static properties give you a place to store data specific to the class that doesn't vary across instances of the class.